Hey guys, I'm gonna turn my lights on real quick. 1 second. I probably could have waited to do that, like to start the stream until after I'd done that, but I thought about it after I'd hit the button. Alright. Let us get started. Need to clean up my little office area. Just so everything's a little bit smoother. Alright. We are set up. Alright, this first question that we have is a very simple one. I just went as dirt simple as possible for starters. So let's go ahead and open it up. Let's see what it opens with. Nope, that's not what I want. So let's open with paint. Last week I set up that this would be that paint would be the default. Oh, too big. Undo. Let's just double it. Okay, so this question was super simple. It's just what is the E of R3? What is the voltage flowing down this parallel leg? This right here, this 5.15 volts is E of R1, which you have 12 volts total. 5.15 volts is dropped on E of R1, and then the rest of the voltage is split, or is not split, but these two legs are parallel, so they have the same voltage. So to answer this question, it's just 12 volts minus 5.15 volts. And we will bring up our calculator. And that's where I did it before. That was the calculator, 6.85. volts was the actual answer. And I'm fairly certain that nobody, that's not the right button, nobody got that. 6.85 was nobody. Alright, but let's work this circuit in earnest. So we need an R, I, E, and P. There's 3 resistors? Okay. This will be it's been a minute since I've used my drawing pad. So let's grab that. Getting a Facebook message. I don't think it's important. Alright. So now Now that we've got our chart made up, let's record what we know. We have R2 is 20 ohms and 40 ohms. E of 1 is 5.15 volts. And this is 12 volts. And 2 and 3 have to be the same voltage. We do need a extra row. Let's make it red. Because we have to combine R2 and R3 at some point. All right. So let's start off by combining R2 and R3 together using the reciprocal method, not Ohm's law. We're not there yet. Okay, so reciprocal method for you guys one more time is open parentheses R1 to the negative first power, or in this case is R2 to the negative first power plus R3 to the negative first power, close it, and one more to the negative first power. Alright, so let's plug in our numbers for it. 20 to the negative first plus 40 to the negative first is going to be, so let's do that. Open parentheses, 20 plus 40, and then 13.33. So this is going to be 13.33. We don't have a current total, but we can find 12 minus 15.5 will give us R23. Because the circuit we have right now is going to be this. Alright, so this is going to be R1 right here, and then this will be R2 comma 3. We don't really have enough information. We know what R23 is. We know this is 12 volts. We know this is 5.15 volts. So if I was asking you what the voltage of R23 is, you should be able to know because of series circuits. So what would we say? It was 6.85? This is 6.85 volts. And we have done several circuits at this point. Whenever you find this voltage and you're splitting it into parallel circuits, well, then you can do 6.85 volts and 6.85 volts. Now, any of these, now you can find current. Let me drag this a little bit down so you guys can see everything. Alright, so voltage, which is 6.85, divided by resistance, which is 0.3425. So that is 0.3425 amps. This amperage is going to be half because of the law of proportion, which we'll get to later. But since it's twice as much resistance in parallel, it's going to be half as much current. Let's see that in action. 6.85 divided by 40. 0.1712 or 0.1713 amps. Alright. And then just for giggles, let's do the bottom one. It's 6.85 divided by 13.33. 0.5139. All right. So now we know the current through 2,3 is 0.5139 amps. What does that tell us? It tells us that the current through R1 is 0.5139 amps, because this down here is a series circuit. We know the current through one item, so we have the current for the other one. So we can come up here and put 0.5139 amps. So now that we have two things on this row, and actually, since it's a series circuit, or these two are in series, it's 0.5139 amps there as well. I've been on this one for 11 minutes. Wow. Okay. So now we can find our resistances. We can find R1 and we can find R total. That's 12 divided by 0.5139. R total is 23.35. Ohms. And that puts this one should be like 9 5.15 divided by 0.5139, 10.02. That's actually, yeah, 10.02 ohms. So now we found all of those pieces. We can come over here to the powers and just multiply across to get our powers. 0.5139 times 12 gives you power total 6.17 watts. And then you can multiply on across all the way down. Powers 1, 2, and 3 will add up to 6.17 watts. Okay. Let's go back to Socrative. Alright, nobody went back and answered this one. Cool. What is the voltage across R1? Again, another incredibly easy one. Voltage across R1 is 10. Because, and let me open up a picture. I'm probably not going to work this one all the way through. So we have R1 or I. Let's do R total, I total, E total, and P total. And the important bits are R1, I1, E1, and P1. We could go on down. We're not going to right this second. We know I total, because that's what this is, because there's nowhere else for it to go. I total is 1 amp. I1. Well, all the current that goes through here, let me use green. All the current that goes through here has to go through R1. And then it has a split right here. So it's going, the current's going to split, but that whole 1 amp goes through R1. So we'll have 1 amp. We have 10 ohms right here. So 10 times 1 is 10 volts. Done. 10 volts. I so like recommend drawing out the whole chart and filling everything in. The chart is going to illuminate things. That's not what I wanted. And make things like obvious. P2, P3, and P4. Okay. So, looking at this. We're going to have several combinations that we're going to have to make. This isn't as easy a circuit as the last one, I believe. Yeah, this is a step above the last circuit that we did. So our first combination, we start the furthest from the battery. Sorry, I blanked on the word. So we start the furthest from the battery we could possibly get. So we're going to start at R3, comma 4. That didn't come out like I wanted. And we're going to have an I, an E, and a P. We're going to have one more combination, so while I'm in the mood for writing things down, and P. This will be 2, 3, 4, 3, 4, 2, 3, 4. New developments. Probably just news. Alright, R3 and R4 are in series. You can see that. Like they're blatantly in series. Any current that goes through one has to go through the other one. There's no ifs, ands, or buts. So what do you do with resistors in series? You add them together. 1 second. 15 ohms, 12 ohms, and 18 ohms. So if you combine 12 and 18 ohms, you get 30 ohms. We don't know the current yet. We don't know the voltage yet. So we're at 30 ohms. Now we have, and I will draw this really quick. We have exactly the last circuit that we did. So now we need to combine these two together. So R2, so let me write down reciprocal method again. 15 to the negative first power plus 30 to the negative first power, negative 1 one more time. All right. Open parentheses, 15 plus 30. Close it one more time. 10. 10 is the answer. So we have 10 ohms. And since the circuit looks like this now, we know a lot more, because this was 10 ohms and this is 10 ohms. Now that we've combined these two together, got 10 ohms and 10 ohms, 1 amp, a series, so we get the 1 amp here, and that gives us 10 volts. When we split between R2 and R34, when we get to here and split it up, well, this is going to be 10 volts and 10 volts. So R34 gets 10 volts and R2 gets 10 volts. 10 volts divided by 30. Let's just pull up our calculator. 10 divided by 30. This is just doing Ohm's law at this point. 0.333. That's going to be, so this is just Ohm's law. E divided by R gives you I, and that is 0.333 amps. R2, R3, and R4. So the resistors R3 and R4 are in series, so they keep their current. So when we split them from R34 to R3 and R4, they're going to keep their current. So we'll record the 0.33 amps and 0.33 amps. And then the other leg, R2, if we look up at our chart, we have 10 volts and 15 ohms. 10 divided by 15, 0.667. That's going to be 0.667 amps. Our total, I kind of skipped that. And our total, so down here, the series circuit had two 10 ohm resistors. So our total is 20 ohms. That makes E total 20 volts. There you go. Now we just need to multiply across. It's going to be like 4 and 6, but I'll do the math. 12 times 0.33, 3.96. volts, and then 18 times 0.33 is 0.594, or 5.94. Alright, and that is all of this one. Now you can multiply across. It's 20 watts, 10 watts, 6.67 watts, 1.33 watts, and 2 watts. And I'm rounding a lot, but that should be it. That'd be 7. That only takes me to 19, so this one might be, that's not, I did this one wrong. R3 is not totally correct. So 3.96 times 0.33, 1.3. Okay. Yeah, this adds up to 19. We're close. We're really close on the power. Okay, let's find our next question. So I did number 2 and number 3. This one I mostly put in if you're not getting something, message me. I'll be glad to explain it one-on-one. Yeah. I mean, I hope people are watching these videos, but judging on the grades and some of the messages I've gotten, there's some people like, yeah, I'm just trying to do it on my own. Okay. What is the current across R2? Okay, let's pull this one up. Open with paint. So, I would recommend just rewinding and going to that last question where I was working it, because this is an identical circuit. Different numbers, but if you adjust some of these resistors, it is identical. So let's draw the brush. Okay, so follow along with me as I trace out this. So you leave the battery, you take a right, you come over, and you hit a resistor. And then, right here, there's a split. We'll trace down this way. Then at the bottom, you hit another split. One goes one direction, one goes back to the battery. Alright, so let's go back to this split right here and trace down here. So there's two resistors in series. And then you join up with that previous split. That is, these two circuits are the same, and this is exactly the circuit that you would be doing. So, in the interest of time, I'll gladly work this one and give you numbers. You can go back and watch the last one. Message me if you want to see this specific one worked. I guess I will go through and give you the answer, which I haven't worked out yet. Okay, what is the current across R2? The one I would want to skip is the one that is going to be the longest to work. I say longest, it's not. Okay, so let's do this one a little bit faster paced. There are 4 resistors, and then we're going to have to combine twice. Let's make R. Hang on, let's just brush. Total 1, 2, 3, 4. 2, 3, and then 2, 3, 4. Then select. And we'll add that to each of these. And I'm just using Microsoft Paint right now, for those of you that are like, oh shit, that's cool. Let's use a green line to, let's actually use a line. Split the real numbers from the made up numbers. I will not be redrawing these. Again, for a full description, see my previous. Okay, we have 100, 270, 330, and 300. This is going to be 600. Our 2 and 3 added together, because they're in series, is going to be 600 ohms. 600 ohms and 300 ohms is going to be 200 ohms. That just works out to my mental way of doing things. I will show you in clear. So open 600 plus 300. Close it. One more is 200. So that's just the reciprocal method. Between 600 and 300 is 200. I've done this enough that I just was able to do that one in my head, but it's nothing. Okay, so we have R234 is 200. All of this combined together turns into one series resistor. Like this. So it's R2, 3, 4, and R1. So all of that combined together, it adds up to 300 ohms. 12 divided by 300 ohms . 0.04 amps. That 0.04 amps is going to be at all of the series resistors. So we have 0.04 amps, and then I234 is also going to be 0.04 amps. Now we can multiply across 200 times 0.04. Alright, so that is 8 volts. So whenever we split E234 into its components, into its two parallel resistors of R2 and R34, they're both going to have 8 volts. So that's R2 has 8 volts and R34 has 8 volts. Let's go ahead and fill out that row. While we're at it, this will be 4 volts, because 100 times 0.04 is 4. Also, 8 minus 12 is 4. And that's, we found this was 8 volts. We have 12 volts total, so 1 has to be 4. R1 has to be 4 volts. 1 has to be 4. That doesn't make any sense. So now we can divide things out. That's 8 divided by 270 is equal to 0.03. We're going to call it 0.03. And I bet this is 0.01 or thereabouts. 8 divided by, that was 600. 0.013. 3. Yeah. No, we're gonna go with 0.01 because it makes things smoother. Alright, now our 2 and 3 were in series originally. So when we split them apart, we keep the current. 0.01 amps and 0.01 amps. So now we can multiply those out to get our voltages. .3, but it's 4.7 for 300. Nope, it can't be. And 3. Let's, for giggles, let's 0.013 times 330. 4.29. That's drastically different. I didn't think it was going to make that much of a difference, but what was it, 4.29? I'll leave that at 4.3 volts. And 0.013 times 300, 3.9. That's much closer to 8, which is what we were looking for. All right. And my touch ID has not been working. Okay. Alright, what is the total resistance? Ooh, this is a good one. This is going to be a long-ass video. I may want to split this up into 2. I should have split this into 2 quizzes. This was a long-ass quiz. My apologies. Probably tomorrow I'll split it into 2. Yeah. So the trick on this one, well, for one, the total resistance is going to be less than, it's not going to be 205. That's not correct at all. So those 2 that are crossed in the middle, that are like this, you straighten them out like that. Because they're not connected in the middle, you can just straighten them out and make, let me open it up in Paint. So those 2, you just make the legs, it's got 4 parallel legs. So you just have, so that's 1 and 2, 5 and 6, 7 and 8, and then you have 3 and 4. So that's R1, R2, R5, R6, R7, R8, and then R3 and R4. So let's just quickly go down the list. 50 ohms, when you add those together, 30 and 10 is 40 ohms. 50 and 10 is 60 ohms. And then 50 and 5 is 55 ohms. So we're going to be somewhere around 20 ohms. 18 ohms on this one. I don't know off the top of my head, but Probably somewhere around 18 ohms. So let's plug everything in. We're using reciprocal method. Open your parentheses. 50 to the negative 1 plus 40 to the negative 1 plus 60 to the negative 1 plus 55 to the negative 1. Remember to close your close your parentheses, and then hit negative 1 one more time. 12.52 is the answer here. So, oh, my tip fell out of my pen. All right. Our total equals 12.52 ohms. That was that one. All right, let's speed right along. So yeah. Total resistance was the question. Was the current through R5? That, man, I really am asking the hardest possible spot in these. So the first thing you have to do is redraw this circuit. And this circuit is absurd. It's absurd. Current through R5. Let's see. Yeah, there's no getting around it. I don't have a trick. This is a difficult question. I believe this question is in one of your lessons, and it steps you through to this. And I'm just jumping y'all to the end of this particular one. Let's see, we are at 45 minutes already. So let's, and this is the last question. Let's skip this one. It's way more than you need. I'm not 100, like, I know how to do it, but I just don't want to take the 10-15 minutes to do this one. Alright, how much voltage dropped across R1 for the circuit shown in the figure below? Given that R1 is 8 ohms, the source... Oh, that gave you everything you needed for this one. Okay. So this one's simple. Open with paint. Alright. We just need to make our chart. R1 is in series with the source. So we have R total R1. I total I1. E total E1. E total was 220 volts, but it's not going to come up again. Let's see. 11 amps and 8 ohms. So 11 amps, 8 ohms. So, in this one, you have 11 amps total. And we're talking about a resistor that is in series with the source. So, it has 11 amps. So, now all you have to do, now that you have two things on a row, 8 times 11 is 88 volts. And done. Alright guys, this was the live stream for right now. Let's see, 88. Hey, somebody got this one right. Oh, and some more, and another. Good job, David, Grayson, and Ryan. Hey, Ryan said he was having issues with this, so good job, Ryan. All right. I'm not going to finish the quiz because a lot of people haven't even touched the quiz yet. I will finish the stream here. Thank you guys for joining me. I'm going to end the stream, and I will see you guys at, I believe, 4 will be my next stream. I'll probably come back and hit that one circuit then. All right. Or 3:45. Yeah, that's going to be the last stream. All right. Yes, I do want to end the stream.